Okay, before break, we'll just think about this integration part. I have just observed one question here. So I think you should 55%, please. Please try. Please simplify. Try to integrate. This one, please. So what do you take as you? Okay, please go ahead. Yes, it's working. You should take two little x as you.
Yeah.
But
We should divide it and make.
no, actually you cannot distribute because it is the denominator. No need for calculate. Otherwise, it becomes because for conjugate you have to multiply and divide. So when you apply conjugate, so in numerator also gets some function. Yeah, actually here we need one step as for simplification. So to integrate dx divided by 4x plus 2x. Actually, if you just observe here, it means if you take, let's say, root x as du, and after differentiation, it doesn't work. So it means we need something else here. So here, yeah, as you said, what we can do here is you have to take as 2 times root x as a common factor. Because if you take the 2 times root x as a common factor, so this becomes 1 plus, do you know what this becomes?
What is X?
Yes, it becomes cube of x. Right. It becomes cube of x. Exactly.
No, it's a Q from this. So,
And now, exactly, now you can take u at 1 plus x.
but you have to come to the square root of X.
Again. Do you understand what does mean by common factor? Common factor means we divide. We divide. So you have taken 2 root x as a common factor. It means you are dividing this 2 root x by this common factor, understand? And also this 2x is basic dividing by this common factor. This is the meaning of common factor. Common factor means you are dividing the inside part by this common factor. Mean this is gone. So how much here? One. Now here, this and this gets out. And now we have simplified this x. This x has power how much? One. And this x has power how much? Half. So do one thing, please. Take this half power out. So x has 1 minus half. So how much 1 plus half power? 1 plus half is half. And half power means square root.
Is it okay to repeat again?
Actually, between these two, we have taken 2 root x as a common factor. Common factor means you are dividing this
Before taking you?
before taking. Yes. Because right now the u is not working.
Yes.
That's right. So when you take the 2 root x as common factor, so after taking common factor, basically you are getting now inside. This is 1 root x. Okay? And I explain the reason how we get here root x. Now you can start substitution. So we take now, okay, what we can take as u?
1 plus square root x.
1 plus square root of x. Exactly. So we take now this part, this part we take as u, please. This one. So 1 plus root x is equal to u. Now please differentiate. Differential. What is constant? Derivative 0. What is the root x derivative? Exactly. Use shortcut. We have learned already. If you have square function, we can use shortcut. So it is 1 by 2 root x and dx is equal to u differential du. Now please observe. Do you have this part in your question?
Yes. Yes.
Dx divided by 2 root x.
Yeah.
Oh yes, look at here. Dx by root x. It's really how much?
Du.
Du. So this is now becomes integrate dx over 2 root x is du. And divide by how much 1 plus root x? Du. And what is du by u? Of course, and absolute value of u, yes. So du by u is ln absolute value of u and plus c because this is indefinite. There is no limit. That's why we put plus c. And please put back u value. What is u value? This
1 plus square root of x.
1 plus square root of x. So this is ln absolute value 1 plus square root of x and plus c, and that's all. We get the answer. I hope you understand. So sometimes, please, you need some, extra calculation before you start substitution because the available of this question means the solution not working. That's why we have done one step before we take solution. Did that it is?
Yes.
Okay. Because some are asking is a difficult question, so I just thought maybe is some question is which is slightly different. So I found this question. So means that's it. I have almost done all the questions. For example, if you observe 56 question, what do you take as you?
I think that x plus
56 question, what do you take as you?
then secant x plus 10.
Yes.
Oh.
And then with the argument secant x plus 10x. Can I please 56 question, please?
Mm.
Come on. Then we start 7.3, please. Please, let's start. Try 56 question. Secant x divided by square root of ln with the argument secant x plus 10x. So is working? The solution is working or not? We have done 55 and now we are doing 56, please. So please check 55 first and then you can try 56. Yeah.
Here after I did, you as well see plus.
Okay, then 1 over argument times argument derivative. So you need secant derivative, you need tan derivative.
When you take common factors, you can.
Actually, this is the bottom line here. Exactly. Good.
We try to have the du should.
So what is the du in derivative? What's the derivative of ln?
Like
1 over argument.
But what about the like the plus sign becomes
It is. What is the argument here?
it's the inside the one.
Yeah, so just copy paste same from 1 over argument times argument derivative. Yes, please. No? These also you have to spec out 55, okay? So, huh? You have 55, yes? Okay. 55. 54. No, no, 55, 55. 55, 55. Okay.
I just think that's. We cancel it.
Exactly, good. And don't forget, because when we take derivative, it's secant x dx. Very good. So. Very nice. Yeah.
7.2.
7 point?
7.2.
It's 7.26. We are working on that. I have discussed two more, 55, 56. 55 we have, now we are doing 56 now.
And can I see the answer of 55?
No. 55 answer is here, yes. This is 55, we answer already. This is 55, please.
Okay.
And then I give the question 56 to try. So you have done?
I stopped at the view or good as it.
Yeah, please get here. Please try now. This is the 56th question.
That's cool.
So for the sake of 56 questions, is we take ln with the argument secant x plus tan x as u. Okay. Now differentiate both sides differentially. So our argument is this one. This is the argument. This is natural log function, and this is the argument.
Yes.
And when you go for derivatives, so we know very well the root. This is 1 over argument. 1 over secant x plus tan x, because the argument multiply argument derivative. Now in the argument we have two functions, secant and tan. So what is secant derivative?
Secant socket
Secant x tan x. Okay, good.
and secant square.
Then we have plus sign tan derivative.
That's secant
Secant square. Secant square. Yes. Tan derivative secant square. Yes. So we have secant square x. And here you differential du. I'm sorry. Also here we have dx. Okay.
Now we will take secant x as a common factor.
Yes, because in both the terms we have secant x, so you can take secant x as a common factor.
Tan
I have tan x.
plus secant x
We have plus secant x
over secant x.
and divide by secant x plus tan x.
Now we can have now we can have.
So, and here dx please, this is the. So you can see this and this is cancelled out. So now, finally you have secant x dx, which is equal to d. Now, do you have secant x
Yes.
in your question?
Yes.
Good. Is value how much?
Reduced.
So after making the substitution, my question becomes like that. Secant x dx is du
Okay.
divided by ln secant 10 is u, and don't forget it has square root, so it has square root. And then you know very well we already integrated the u square root means take it up, it becomes u power minus half means for the sake of integration, take u squared up, it becomes u power negative half. And now use power rule. N plus 1 divided by n plus 1. And for the sake of n plus 1.
Negative half, 1 is half.
Exactly. So you have u power minus half plus 1 divided by minus half plus 1 and plus c because it is indefinite. There is no limit. So minus half plus 1 is half.
Yes.
Divide by also half. Half will flip. It gives you basically 2 times u power half. Am I right?
Yes.
So after these calculation, please. This calculation gives you now u power half. Divide by half will flip. It becomes 2 and plus c. Please put back u value. What is u value be substitute? Look at here.
ln secant.
ln with the argument secant tangent. So this u is now go back to u which is 2 times ln with the argument secant x plus tan x. And look at here, it has half power. So half power means square root and plus c. I hope you understand.
Yes. We can't simplify now.
No, you can't. You can't. There's no more way. That's the answer. Right? So this is the, as I told you, 99% integration question we answered by substitution is by you, please. Because if you look at the question here, means right now it's very complicated. But when you start substitution, look at here. After substitution, this question becomes like that. So is expand form with u, it becomes reduced. Look at here. That's why it is a power of substitution. Okay, so I try, maximum question here, please. Now it's your turn. There are a lot of questions are here. You can try, please. And please let me know if you have some doubt in some questions. List down. Note down the question and ask in the class. Okay, or you can visit my office, please. If you want more, sit with me, one to one. Okay, most welcome. Right. Now we have to go with 7.3, please. Now, so in 7.2, the function was natural log. We differentiate, we integrate, understand? Now, in 7.3, please. Exercise number 7.3. We know what is the inverse of log functions? Exponential. That's why the topic in 7.3 is exponential functions. Exponential functions. Okay, when we discussed 7.2, I told you that the derivative means differentiation and integration is not possible for which law? Ordinary law, common law. Common. LOG is LOG, LOG derivative and integration directly not possible. That's why if you observe, we only discuss the questions related to natural element. All the questions of differentiation and integration were related to ln. Clear? That's why in 7.3, when we go for inverse function of ln, what is the inverse of ln? Of course, it is exponential, but with which base? E. ln has base e. Okay, so that's why we are talking about exponential functions, particularly to base How much, please? E. Because the base E exponential function derivative and integration possible. Base A integration and derivative not possible directly. It is possible, but not directly, please. You cannot directly integrate 2 power x. No. E power x, yes, we can. Right? Okay, so before we go with the the differentiation, let me show the first of all the rules. How you differentiate base E exponential function. I think you have the idea of the graph of y is equal to e power x. Actually, we are not interested at all in graph, but okay, to some extent, we should know the basic graph of the exponential functions, please. So this is the graph of base E exponential function. Sorry. This is y is equal to e power x. Y is equal to e power x. Graph, okay? Right. Please tell me, is there any asymptote available here? Yes, please.
Yes.
So x, do you remember in the log function,
Yes, it was.
asymptote was vertical.
Now horizontal.
Now it is inverse. So exponential function has horizontal asymptote. Understand?
The x.
Yeah, and by default means in the basic function in the x-axis. You're right. Okay. What you can observe any other thing in this graph? Any other something special you can observe? Come on, please, because that is important thing.
Section.
We use that thing in our next topic. Just asking. What do you observe here? Huh?
Increasing.
It is? Okay. If you just use this in using another way, so become more convenient for us. It is? Yeah, good. Exponential function graph is positive. Yes. Very good. Look at the values of y. All y are above the x-axis. Yes or no? Yes, good. Exponential function, the basic exponential function, the positive. Because we will use in some other topics, next topic, we have to use this fact. That exponential function is basically the positive function. Yes, good. Good observation. Very nice. Anyway, now before wasting time, let's start. First of all, I share with you. If you have y is equal to e power x function, how you can get y prime? Again, please, is a chain rule. The chain rule, please. Same like ln x. So we learned ln x as 1 over argument times argument derivative. Okay. Similarly here, for the sake of y prime, is a chain rule, please. What is that? Y prime. Copy paste same function and times the derivative of the power. Derivative of the power, please. The chain rule, don't forget. Because in a basic function, power is x. That's why ex derivative is same, ex. Because power is x. So when you drive x, x derivative is 1. That's why ex derivative is ex. Okay? That's why. And this is concept cancel. So y prime is e power x. But anyway, please keep in mind how you differentiate. Copy paste same function, multiply the derivative of the exponent. Whatever exponent you have tried, differentiate. That's the chain rule. Understand the rule?
So for example, we have e to the power 2x, so we
Yeah.
will write e to the power 2x times 2.
Times 2. Yeah, I will give you another example. Let's say you have y is equal to e raised to power minus cosecant x. E raised to power minus cosecant x. So please give me the y prime.
E to the power negative.
Copy paste same function, e raised to power minus cosecant x times the derivative of minus cosecant x.
Go
So
down.
what is the cosecant derivative?
It's gonna be positive because
Yeah,
negative makes-
so because, okay, I'll show you one more step for you. So e power is copy paste same function times the derivative of minus cosecant x, please. Now you can write, by the way, I just do the step for your convenience. No need to show the step, please. Write directly, please. What is cosecant derivative?
secant.
Cosecant derivative how much? Huh? Negative cosecant cotan, yes,
So it's gonna be
negative.
positive.
We already have negative here, so it becomes positive. So finally, we have here e power minus cosecant x times cosecant x cotan x. Yes, this is the answer to this question, please. So I hope you understand how to differentiate exponential function to the base e. Base e, okay? Good. By the way, this topic is not very complicated. It's very easy. You don't have any question which is something more difficult. No, I can show you. Let me check if I have zero from the world. I can try. Because it's easiest topic in calculus 2, the differentiation of exponential function based e. I think even the integration aspect is easy. So you told me the book is not opening to you. All of you have same problem?
It's open for me.
It's open? So I think, please just check one more time.
It's not open for me.
You have iPad?
I think from the mobile, it doesn't open.
It doesn't talk from the outside.
No, iPad is opening, huh?
You have to allow.
You have to apply?
Allow.
Okay, please check, maybe some folks are blocked, so you have to, you know.
I think you need laptop because then the iPad is open.
Please contact to ID department, maybe they can give some solution. So, sorry. So it takes it's.
It's called.
Just about
Not much.
It doesn't open from there.
so it's 7 chapter here.
Okay.
Oh, okay. No, it's
No,
like,
it doesn't open from here. You have to go from the first,
on first page?
yeah. And then you move down.
Okay, you try. Okay. Here. So I have now index content.
Yeah. Yes.
Then here, okay, so it's content. All right, so we have sugar 7 and now it's 7.3. Okay. So here is 7.3. This is 406, so maybe the size 415, maybe. Yes, here. Okay, So you can see here means we have here 7.2. This is the derivative questions, please. So let's try this number 10 question. So this is the 10th question. Y is equal to e power 4 root x plus x squared. Number 10, please. Question 10. Y is equal to e raised to power
About four,
4 root x
yes, plus x squared.
plus x squared. And we need find y prime. So we already discussed the formula, please. We know very well when you go for y prime, this is base e exponential function. So what you have to do, please just copy paste same function as it is e power 4 times root x plus x squared and times the derivative of the exponent means the power derivative. So in the power we have two functions. One is the root x times 4, the other is x squared. So its derivative is 4 is the constant, see as it is.
1/2.
1/2 with root x, because this is the derivative of root x base.
Plus
1/2 root x. And then x squared is plus 2x. This 2 and 4 is cancelled out. So finally, you will see that this is basically y prime is equal to e raised to power 4 root x plus x squared and times 2 over root x and plus 2x. And that's all. This is the derivative, please. So copy paste same function, multiply power derivative.
By the power only.
But only power only. So in the power, you can see we have two functions, root x and x squared. X squared derivative is 2x, okay?
Okay.
And 4 times root x derivative. Actually, we are using here a shortcut for the root x derivative. Okay, maybe you have the idea. So for example, if you have square root of x and you need its derivative, the shortcut is that copy paste the same function down with half, with 2, the copy paste same function please with 2 and multiply derivative of inside. So inside is x. How much is derivative? Is 1. That's why square root of x derivative is 1/2 root x.
It was maybe 2x, doctor. Like,
Yeah, for example, you have, let's say, I have 2 minus x squared. I need its derivative, please.
1/2.
So, yes, copy paste same function with half 1/2 into 2 minus x squared times the derivative inside.
minus
So inside you have 2, so that will be 0.
0, minus 2.
And minus x squared derivative is negative 2x. So this is cancelled out. So this is the minus x y, this is the derivative.
So can we say it like the derivative of the inside over double?
Yeah, you can do like that. It's fine. It's fine. Yeah, please.
Well, for 4x, we're using the product rule, right?
No, 4 is constant. So if a constant is multiplying with function, in the derivative, constant not change. Keep as it is.
So take the derivative of 4 and root x.
4 no change. Root x derivative. Clear? Oh yes, if it's not 4, it's x times x square root. Means x square x, then they have product. If both are functions, variables. Okay.
So chain rule, right?
Yeah.
Chain rule, right? For
What?
you.
No, look at it, please. If you have this like that, e raised to power x squared root x plus x squared, for example. Now, if you have this one, so for the sake of the derivative, this part, then you can apply here product rule because both are functions. Actually, even no need, you can simplify, but it means the sake of understanding. If both are, x, then you can use here product rule. Right now, it is 4 and then you have a function. This 4 is a constant, so during derivative, remain as it is, no change. Okay? Right. So as I told you, means it's not something difficult here in this part. In differentiation, 7.3 is quite very easy, by the way. Okay, let's try this question number 24, please.
It's not 20.
20? Where's 20? Okay.
24.
Okay, 20. This is y ln and the argument 2 times e power minus t sine. Okay. 20th question, please. 20th question, please. 7.3, question number 20, y is equal to ln with the argument, how much? So 2e power minus t, 2 times e power minus t times sine t. That's it?
Yes.
Find y prime. Find y prime. Okay. Right. Now I think it's very easy because you can see this is the argument, right? Because function is natural log. We have log function. So if it is log function, so this part is argument. And all are, multiplying. So before to start differentiation, please simplify them. So ln 2 plus ln e power minus t plus ln sine t. Can I write my question like that? Because argument has product. So if the argument has product, you can add. Addition comma. Understand yes or no, please? Okay. We can do one more step. We can do one more simplification. Look at it. ln 2. This is e, which is the argument. It has power. So whenever you have a power of the argument, we can take it down. So it becomes minus t, then ln e plus ln sine t. And we know very well, ln e value how much? Is 1. ln e is always 1. Yes, ln e is 1. ln 1 always 0. And ln e is 1. So you can write now my question y is equal to ln 2 minus t and plus ln with the argument sine t. So look at here, you have simplified your question until this step. Yes or no? We can simplify. Now you can differentiate. Now it's very easy. So y prime, please, y prime. What is ln 2 derivatives? Are you sure? No, the arguments. Yeah, 0. ln 2 is a constant, please. So any constant derivative 0. So ln 2 is constant, derivative is 0. Go next, please. Minus t, that is 1 plus. What's the argument here? 1 over sine t times sine derivative how much? Cosine. So finally, yes, cosine by sine is cotangent. So y prime is equal to cosine over sine is cotangent. Cotangent t minus 1. I'm sorry, I just first I write positive value, then I write negative. Or minus 1 plus cotangent t, please, it's same. 1 plus 2 or 3 plus 2. So 1 plus 2, 2 plus 1, same thing.
Can you multiply -1 by cosine comes negative? Or
No, it's not multiplying, it's a 1 value minus 1 and addition, okay? So it is, so I just write first cotangent, then I write minus 1. Or minus 1 plus cotangent is same. Understand now? How to differentiate this part, this question? Because if you have argument, oh man, you can use the properties. So the question becomes very easy for you. But you should know the properties of log, how you can apply these properties in a correct way. Okay, please take a look. If you need some more other question, please, because I can start then something related to base A, base A. 24? Okay, we can go for that. Why not? So 24,
Objective number 3.
20, 26 is what? Is an integration now.
The second one, here you will say.
Huh? What is that? Yeah, good. This topic actually, no need for that. Don't do this topic. You know, this 25, 26, and in 7.2 is also some question like that. They are related to fundamental theorem of calculus. You know,
Yes.
calculus 1, chapter number 5, section 5.4, where both the limits, sorry, here, both the limits are function. Here, one of them is a function, which is the same like calculus 1. Here, both are functions. So here it's like different. But we use FTC, of course. So I think it's better, no need for that, no need. Right. So you're talking about 24 question, please? Okay, so in 24, E sine T and T square plus 1. Okay. So 24, please. Question 24. Y is equal to E raised power sine T, right?
Yeah.
Times
11 t squared plus 1.
ln T square plus 1. Okay, we need one point, please. We need one. Okay. Right. Now, it's up to you how you treat this question, please. Means, okay, if I ask you that, how do you answer this question? What do you do?
Thanks, fun. Yeah, maybe.
You be like, huh? ln?
And then you
Actually, ln becomes more complicated.
can answer because we have can we use product rule?
Yeah, okay, yes. One of the option we can say this is U and this is V, yes. Or, as you said, what we can do?
Fun.
We can expand, yeah, means this time this and this time this first, and then we can differentiate. I think expansion is good. It means E power sine T, and this is 2 ln T. Yes or no? Question? How I get 2 ln T? Come on, guys. It's a property because this is the argument. Argument has power. So we know very well. This is natural log, please. It has argument T. T has power, so power can come down.
You can't use property because
No, please. If argument has power, you can apply it. T square is argument, yes or disagree. T square is argument, you can apply. If argument confirm, it has power, use property, no problem. Yes.
Plus E to the power of sin T.
Yeah, now next,
Yeah.
plus E power sine T, yes, E power. So what we did first, we just distribute, and during distribution, we have noticed that this is the argument, it has power, so we take it down like that. Understand point? Okay. Now, yes, now again, you have this one function, this is second function, so you can use their product rule. 2 is constant. Okay, let's one prime. So 2 is constant, keep as it is, don't change anything, because 2 is constant, it's multiplying, keep as it is. Here you can use UV, U prime V plus UV prime. Remember the rule? The U prime V plus UV prime, product rule, okay. So first of all, drive E power sine T. So E power sine T times power derivative, how much? So sine T times V, which is ln T. So basically, this is U prime V, then plus. Now U, which is E power sine T. Now V prime means ln T derivative. How much? 1 over T. So please, I just finished this one. This is the answer of this one, please.
Plus
And now, now drive E power sine T, please. So plus E power sine T
as it is, then
and I what?
the cosine.
Cosine. I don't think so. It has something else. This one?
Yeah.
I tried this one.
Oh.
So copy paste same function. multiply power derivative.
So product rule and.
Yes, here we use product rule, here we use exponential E rule, that's it.
You can simplify.
So outside.
Because two is constant, it's multiplying.
It's like some factor.
Yes, it's okay, yes.
It's okay to take E as common factor of each side.
Yes, means for the purpose of simplification, you can take e power sine t as a common factor, yes, right? So, but in that case, you have to basically distribute two inside first of all, because two is not common there, okay? So, yeah, you can take e power sine t as a common factor. So what we get here, 2 times cosine t ln t, okay? Then you have plus 2 over t, and then you have plus cosine t.
Not a common factor is still good.
It's okay, it's okay, no problem. It's okay. So this is the differentiation. As I told you, differentiation is not something, complicated in exponential. Even integration is not very complicated because the derivative of ex is same ex. And let's see about the integration. Okay, before I go to integration, let's complete one topic, means where the base is not e, means how we take the derivative of base a.
Same thing, but is base.
No, means the base is now some constant.
Same C, but you're not learning the base.
Yes, we, of course. This I have to discuss with you. Yeah, sorry. First of all, the sequence, mean how they are giving the questions in the book. Okay, so we have the derivative question of base e, okay. Then we have integration. Okay, so we follow sequence, no worries. Okay. Regarding the, look at here, differentiation, 27 to 32, they have some special questions. 3. There are 6 questions, please. And we need derivative. Come on, please, just try. Could you please try this 27 question?
So 29%.
20. Uh-huh. All are implicit, by the way. 27, 32, all implicit. Come on, please, try it. Let's try 27, please. What we need here? What do you need? What is y prime? Our objective is y prime. Kindly try 27. Because 27 to 32, same concept, same way. So please try 27, please. Then we proceed for integration. So we need y prime, okay? 27. And then y is equal to ey sine x. Here. 27. Y is equal to ey sine.
Is product.
E is for y sine. And we need y prime. Find y prime. So y prime is equal to. So this topic you have done in Calculus 1 in section 3.7. It's called implicit. Yeah. So yes, have you got the y prime?
What's tax?
Y, okay, how much? Put n x. Y, put n x. That's it. So she has answered y, put n in x. Let's check the answer. We have answer because this odd number question 27. We can check the answer.
Answers.
Yeah. So we have chapter 7. Equal to 7, maybe on page number maybe 35. Let me try. Or 9, okay, go back. Made a mistake? So what's the correct answer, please?
Sin x, over 1 over y minus e over y sin x.
10.6 is then we have 7.3. Okay. Which question what we have done?
Just
27. Look at the answer 27. Y e power y cosine x divided by 1 minus y e y sin x. Same? Very good. Yes, answer. Very nice. Any other student has same answer? One. Same answer? Good, very nice. So, let's try this question, please. So, as you know, it's very clear here because you have the combination of two variables. Okay, it's very interesting. All are y's. Huh? We have x somewhere?
Excellent.
Sin x. Right, okay. Now, we have to perform derivative both sides because our target is y prime. So we know very well, what's the y derivative? What about y?
Times
Y prime. Okay, good. Equal. Now here, product rule. Yes. So u prime means is e power y times y plus e. Yeah, so we have times v, which is sin x. Sin x. Then we have plus ey as it is, sin x of sin x. Okay.
I can take either e to the power y as a function, or there is no e.
No, actually, there is no one factor between these two.
E to the power y.
No, wait. Our target is y prime. So please try to take one factor y prime. So select only y prime terms one side, please. So here we have y prime, yes or no?
Yes.
So here we have y prime.
Yeah.
So this term we can move this side, okay? Because my objective is y prime.
Doctor, we keep the y prime aside, like in a
Yeah, we have to take y prime one side completely, right? So this is y prime over y, bring this here, minus y prime sin x is equal to y cosine x, okay? Yes, you can do this thing, but right now, you cannot do like that because if I multiply both sides y, so this y will be distributed here. So do one thing, please. Do one thing. This is fraction, and it's not fraction. Make is also fraction means make the common denominator, please. So down is y. I need y. Same. If you are multiplying down, also up. It's called common denominator. Yes or no? Now means after the common denominator, what we get here is common denominator is y. So what you have up y prime minus y e power y prime and sine x. Other side is ey and cosine x. You understand? Yes or no? Okay.
It takes y prime.
Now we can take y prime as a common factor. Yes. So please take y prime as a common factor. What do you have now? 1 minus y e power y and sine x divide by y, and this side is ey cosine x. Do you understand what I did? Now we do cross multiplication. So if you do, no, sorry, not cross multiplication means this y basically. Actually, I don't need this one. I don't need this one. Why? Because I need only y prime. So what I do, yeah, means you can multiply both sides by the reciprocal of this one. Okay, or if you move this other side, what happens? Well, this one will go this side, it will split. Do you understand the point? So this y prime is basically equal. This is ey cosine x. Now look at here. When you shift other side, it will flip. This y go up, means it's become y, and divide by, what is that? 1 minus y, ey, and sine x.
You did cross multiplication for one, right?
Actually, don't, it's not the cross multiplication, because cross multiplication means you multiply this by this and this by this, so you have one more equation. Then again, you divide by this factor. It works, yeah, it works.
What's our objective to get the y prime?
Yes, our objective is y prime.
Sir, can you please repeat the last step?
This one?
Yeah.
I think I should go with other way. Maybe you have some confusion, don't worry.
Doctor,
Yes, please.
uh,
Okay.
you can.
Okay, right. I can do the cross multiplication. So,
When you make it to that side, you get minus to keep it plus, we flip it.
no, please, when you send the other side, means if as a product, if you send, no sign change, please, no. Right now, this factor is multiplying. So when you send other side, no sign change, please. The sign change, if that part is adding or subtracting, then if you move on the side, then sign change. If the factor is multiplying or divide, when you send other side, sign not change, please. Yeah.
Doctor, the e power y cosine x, it will keep on the numerator.
Yes, of course.
But how is that?
Because we have from the starting, this side.
Because it's like basically
It has no y prime, so I keep it here like that.
because it's over one.
Over one, yes, please.
To not deal with this issue, you can take the y from the beginning to the other side, and then you just need to deal with that.
We have, sorry, we
If
can.
you go back to the step where you.
This y on the side.
Just take off the factor, you don't need to think about it.
Okay, actually, but means it's only happened with this question. The question will not like that. So the concept should be like that, which you can apply everywhere. So please look at here. Because I don't need this part, because I only y prime, so I have to cancel this one. How I cancel? I multiply this side, look at here. Y divided by 1 minus y, ey sine x. Same quantity I am multiplying here, which is basically y divided by 1 minus y, ey and sine x. I think you understand now. So what happened? This cancel. So we have only y prime, which is equal to what? Y, ey cosine x, and divide by 1 minus y, ey and sine x. I hope you understand now.
With this cross multiplication, will be more than.
Actually, not difficult. In that case, you have to do two more steps. But yes, you can reach your target. Yes.
Exactly, just.
Okay. So this is implicit. Okay, means this 27 to 35 means the 6 questions are basically implicit. You have done already in your calculus one. It's not any new concept, please. So let's start the integration now. So I just shared with you the formula of the integration of exponential function base E, okay? And then we'll see some questions. So please note down if you have e power x dx, the integration is what?
Also, it is a power x.
Exactly, e power x and plus c. Or as I told you, mostly we go for substitution, EU du. So it's basically EU du is what? EU and plus c. Say like one rule, which is du by u or dx by x, okay? It is ln x or ln u, so same like that. So please, just note down, EU du is basically EU. Oh, now let's start the exercise, please. So I have to go back to my settings. Okay, anyway, I can open the themes, it's fine. So let's go with the integration questions, please. I think start from here. Yes, here. Finding integrals.
Having some another question from the implicit.
From the
Implicit.
implicit. Actually, I told you, you have already done this implicit part, please. So just try at home. If you have some doubts, I can answer because it's not something new topic. We have done already one question I answered. Please now practice, please practice. And if you have some doubt here in these questions, please, I will answer. No worries. So first you try, then inshallah I will answer for you. Okay, so now from 33 to 54, these are the integral part of the base E exponential function, please. So why not we answer 48, please? 48 question. So pi by 4 to pi by 2 is limits, 1 plus e equal 10 and cosecant square. Okay. So 48 question, please. Question 48. This is integrate
From.
so pi by 4 to pi by 2. So we have pi by 4 to pi by 2.
And brackets 1 plus,
1 plus e power cosecant theta
yeah,
and times
cosecant squared.
cosecant square theta and d
D
theta. Okay. So now here we have to integrate this part. And what do you think? How we integrate this?
Can we use U substitution?
Okay,
As
so
one.
if I take substitution, what I take as u?
And brackets 1 plus e to the power of 10.
1 plus e power 10 as u. Then what's the derivative of your substitution?
E to the power of 10 theta times cosecant squared.
So you only have cosecant square. There's no e to 10.
So
Yeah, please. Come on. What do you take as u?
Equal time to.
Yeah.
Equal time.
I'm sure, equidistance u. Because if you take equidistance u, the next step is derivative.
Yeah.
So you copy paste again equidistance. Only the, yes, basically, we take only the power as u. Means it becomes, let's say, let's take cotangent theta as u. So cotangent theta is u. What is cotangent derivative?
Negative cosecant.
Negative cosecant square theta d theta, u differential d. Now, if you compare your calculation with the question, actually almost same, all difference is that we have minus sign here, but in the question there is no minus sign. So what you can do, you can transfer this minus sign here. Yes or no?
Yes.
So this one you can mean negative sign both side. So this negative sign you transfer here. So now it's very clear that cosecant square theta d theta is negative du. Guess please. Cotangent derivative is negative cosecant square theta. Yes or no? Now, if you go back here, I don't have negative sign here in the question. So this negative sign is extra for me. So I don't want negative sign. What I did, I divide both sides by -1. So when I divide both sides by -1, this is cancelled. It's cancelled out. I have now cosecant square theta d theta. However, this side is negative a. That's it? Okay. Come here now, please subtract these values, please. So I have to integrate 1 plus e power u and cosecant square theta d theta is
We
negative,
can't take the negative outside.
and we can take this negative outside. Yes, right. So after substitution, I reached here. Understand me?
Yes.
Okay. Now what should I do?
Integration.
How?
Negative u plus e to the power.
Negative. Yeah, okay. Good. Basically, you can distribute this. So here, negative sign, integration of 1 du. Again, you have negative sign, integration of e u d u. Do you understand? I just distributed these into a sign one by one. Means integration of 1 and integration of EU. Okay? What is DU integration?
Negative u.
Yes, good. So this is negative U. Good. What is EU DU?
EU.
I just shared with you. EU DU is basically
Negative eu.
EU. And don't write plus C before it has limits. It has limits, please. So put back U value. What was the U value? Cotangent. Check it. U is cotangent. So please put here cotangent. Look at here. Minus sign, it is cotangent theta. Then we have minus sign e power cotangent theta, and they have limit from where to where, by the way? Limits.
From 5 over 5.
5 or 4 to
5
over. And now please go ahead and substitute this upper and lower limits, please. So we have negative sign, cotangent, upper limit is 5 over 2, please. Then minus e power cotangent, upper limit 5 over 2. So I have substituted upper limit in my answer. You understand?
Yes.
Then minus, use the bracket because I have two values. Now use lower limit. So minus cotangent 5 by 4. And then we have minus e power cotangent 5 by 4. So do you understand? I just put the upper limit lower in my answer.
You get the
This part is the upper limit and this part is a lower limit.
Just substitute.
We just substituted, yes.
But
Okay.
can you get the values on the calculator? Or?
Yeah, means I think it's better if you use their calculator.
And instead of.
Check.
one,
What is
like,
oh,
one
but the thing
over
is
one
there,
other side.
you can, yeah, you can write cosine in your calculator. You can write here cosine over.
Sine.
Yeah, so it's the best option of these.
Or one
So
over
what is the answer of 1/10? It will give error.
The
Okay.
answer of E.
So cotangent, the simplified form of cotangent is cosine or sine. So please use here cosine or sine.
The answer is one.
Is another one? Okay, very good. So first of all, please give me the answer of this one. Right here, write this one. Negative cosine pi by 2 over sine pi by
0.
0. Yes, good. It is 0. It makes sense.
It is the same thing either to.
Minus here is 1. Okay. Minus sign. I have bracket here. How much cotangent pi by 4 with negative sign? Negative 1. Very nice. This one? E? Okay. Please, they are using the calculator here, please, so you can get the answer directly. Now, please, simplify last step, please. This is minus 1. Again, minus is plus 1. This minus is plus E. This is cancelled out. So the answer, how much? E. Please.
You should get it like this in the exam.
Of course. Must. Not honestly, you have to do this. Okay, so this is the basically finalized simplified answer, please. Right? You understand how we get these values 0, minus 1? Because you just put please cotangent, you can write in the calculator, right? Cosine over sine, please. E power cosine over sine. Okay, same like here, cosine over sine. So E power cosine over sine. I hope you get the idea. Okay, very nice. So basically, this is the integration of base E exponential functions. Let's continue. We can take any questions, please. Sorry, I have here. Okay. Now, please try yourself now. Let me select the question for you. No, it's different position. Okay, please, you can try 47 pound. Please, 47, please. Try 47. This is 47 question, please. This one. And share the answer, please. Almost same like 48. Almost same. In 48, we took cotangent as 0.
Here down.
Here, 10. Yes. Come on, please. Let's see what's the answer to this question. Okay, we can see. I just introduced, the base A exponential function, how we can make differentiation. That's it. Yes, please, get the answer. Yes, please. What's the answer? E.
E.
E. Okay. So it means 47. Or should have same answers.
E.
Have you? Anybody has also E also?
Yeah.
One plus it.
1 plus E.
Question.
See. Yes, please. Is 1 plus E? Only E. Else we can check if it's working. Is working. See? Okay, so it was 47? 47. Oh, yes, you're right. It's E. Good. So here is E. Very nice. Okay, so this I will take some, questions quickly. Related to now, exponential. Look at here means now we have differentiation of these. But take a look. 59 question. Is it base E? No. It's base A. A means any constant other than E. So if you have base A, how we can take the differentiation things. So this topic now I have discussed with you. Okay. So what we'll do here, basically, first of all, what we do, we change base A into E, and then we differentiate. Okay, because directly we have no rule. What is the derivative of A power X? E power X, we know. E power X derivative E power X. But A power X derivative, no, it's not available. So what we do, first of all, we change base A into base E, and then we differentiate. Now, what is the way to change base A into base E? Please note down. So if you have base A and you want to change into base E, so please, this is the way. Look at here. I have base A power X, means this is base A exponential function. This is exponential function to the base A. I want to change into base E. So what I can do, look at here. It is called E power X times ln A. This is called conversion. Base A into base E, please. Now, for example, we have here question number 59. Y is equal to 2 power X. So we have here question 59. Y is equal to 2 power X. So we very well know it is a base A. And the question is find Y prime. Unfortunately, we cannot differentiate directly. So first we use this conversion rule and we change into base E. So please tell me how I write to power X,
So
please.
it's E to the power X then 2.
E power X and ln 2, because this X is representing the exponent and this A is representing the base. So look at here. My base is 2. So E power X times ln 2. Now you can get Y prime. Y prime. Now we know very well the rule of the base E exponential function derivative. What is that?
Is E.
Copy paste same function.
Times
What
the
times
derivative
we
of
do?
Yes. So E power X ln 2 as it is times the derivative of the power. The power is X ln 2. Yes or no?
yes.
Okay, good. Now please.
And then 2 is
D.
Now look at here. This is base E. My question is not in base E. My question is base A. So kindly put back in A. In answer, put back into A. Do you know how to put back into A? How I write this base E into base A, please? It's very easy, don't worry. 2 is what? 2 is what? Argument. Very good. Adjacent to log, this portion is called argument. Whenever you need base E into base A, so only do one step. This factor become the power of the argument. That's it. Means argument how much?
2.
2. What is the multiplier here?
X.
Just write 2 power x. So base E changed to base A. That's it. Times I need is derivative. What is the derivative of x ln 2? Simply ln 2. Why? Because ln 2 is constant. Keep as it is. And what is x derivative? 1. That's it. This is y prime. That's all.
I can't reduce from the first, like, what do you have to do?
You can do from the.
First.
Yeah, I think you're using another rule, right?
Yeah.
Yeah, so you can use that. You can use that. No problem. One last question, please.
That's it. That's it.
One last, that's it. This is your turn now. So I have here 3, okay, 4. No. Okay, 5 power minus cosine 2t. 70 question, please. 70. Question 70. Y is equal to 5 power minus cosine 2t.
Is that
5 power minus cosine 2t. Please, I need y prime, please. Y prime. Come on, please.
actually?
So, of course, we change into, of course, into E. Yeah. So how we change, please? Yes. E power? Come on. E power x. X means power. The power. Oh, yes. Same power. E power x minus cosine 2t times ln base. Base is 5. So ln 5. Absolutely correct. Good. Now, that's it. So we got base E. So please now differentiate y prime. We know very well copy paste same function minus cosine 2t ln 5 times the derivative of the power. Please help me how I take the derivative of minus cosine 2t times ln 5. Okay.
Can I use for the calculator?
No, don't need these because ln 5 is constant. Keep ln 5 as it is. No change, please. ln 5 is a constant. I explained many times, if a constant multiply, constant in derivative, no change. Just simply calculate minus cosine 2t derivative.
It's negative sign, so negative with negative.
So I have negative already.
Positive.
Cosine 2t gives me negative sine 2t. So negative, positive. So look at here. I have sine 2t times angle derivative, which is 2. Now, please, put back in base A. What I told you. The argument, this becomes the power of the argument. So how I write this one, please? 5 power how much? Minus cosine 2t. Very good. And here I have 2. Okay, you can put 2 here, no problem. I have 5. I can put here 5. I have sine 2t. And that's it. So this is the answer.
It is multiplied by 5.
Oh, of course. But please, it's not y, it's a base E. Sorry, base E is x. So you cannot times, no, please. You cannot multiply this by 5. Don't write 10. Okay, so anyway, please go back to home and open these sections and try to correct them, please.
Like why not we have to change it like to base E then back to base?
Why? The reason is that the question is in base A. So the answer should be in base A.
Like the
Yeah. Okay. Good. Yes, please.
For example, the big.